Good day, ladies and gentlemen. Today we are going to be speaking about a very important theorem in grade 12. That is a proportionality theorem, which is going to come out in your exams and then in your test as well. And it has a lot of marks. All right, ladies and gentlemen, we are going to cover a few things in proportionality theorem. So at the end of this session, you should be able to answer 5 questions. Number 1, what does proportionality theorem say? What does it say? You should know what does the proportionality theorem it says. Number 2, you should know what does it mean. You should not only know what it says, but also what does it mean. And then thirdly, when do we use proportionality theorem? And then lastly, how do we use proportionality theorem? Not actually lastly, lastly. And then lastly, we need to know how do we show that we have used proportionality theorem. So if we have used proportionality theorem, how do we show that we have used it? And then on the other video, then we will deal with what? With a proof of proportionality theorem, because a proof of proportionality theorem is examinable, which means that it will come out in the exam and you will have to know how to prove it. So at the end of the session, you should be able to know all of these things and you should be able to answer all of these questions. All right, let's get straight to the point. Proportionality theorem. Number 1, what does it say? A question can come in the exam and say state proportionality theorem. So you will have to know how to state it. It says the following, ladies and gentlemen. It says that a line drawn parallel to one side of the triangle divides the other two sides proportionally. Other books says a line drawn parallel to one side of the triangle divides the other two sides in the same proportion. So when somebody says proportionally or they say in the same proportion, those people mean one and the same thing exactly. So do not be confused. One of the things that confuses people in this chapter is terminology. So I am going to take you through in all of these things that I'm going to be doing. I will be dealing intensely with the terminology that is used around this work so that you can be able to understand it. Okay, now, so we know what proportionality theorem says now. So what does it mean? So it simply means, ladies and gentlemen, if I have a triangle like this. So if I have a triangle, here is a triangle, and then if I draw a line, let's say this triangle is A, B, C. If I draw a line and then I call this line D, E, and then this line is parallel to one side of the triangle. Now, this theorem tells me that if I have something like that, then that line will divide the other two sides of the triangle in a proportional manner or in the same proportion. So guys, what do we mean by same proportion or proportional? This simply means that same ratio. Now, another person can ask me, what is a ratio? A ratio is simply something divided by something. So if you've got a number divided by another number, whatever number they are, that is what? That is a ratio. So here, if I say now this line that I'm talking about will divide this side and this side in a proportional manner, if you express that mathematically, what you simply say is that if you take this side, which is AB, and then this side from here to here, AD, and then you divide it by DB. Now that is going to be equal to what? Equal to AE over what? Over EC. All right, you say this side divided by this side is equal to this side divided by the other side. Now this is what this theorem tells you. All right. Okay. So now if you have this kind of a theorem here, then you can be able to use it in different situations, because that is the situation again that we have to answer this question as when do we use this theorem. Now we know what the theorem says, and then we know what it means, and then now we are saying when do we use it. Ladies and gentlemen, let's say we are given this triangle, and then we are given this side and this side, and then this side, and we are looking for this side. Then we are going to use this kind of a theorem. But and then also, let's say you've got this side and this side, and then this side, and then you are looking for this one. You are going to use this theorem as well. All right. So you will see. And then I want to deal with another question. Now, let's say we have used this proportional theorem. Now, how then do we show that we have used proportionality theorem? There are two ways. You can choose any of the two methods. Right? You can choose any of the two methods, and then that is what we refer to as a reason. So when you are writing a reason, you are going to open a bracket. So you can say line parallel to one side of triangle. Now this is one of the ways in which you can show that I have used this theorem. So whenever you use something like this, therefore you must have this reason coming with it. That I'm saying this because of a theorem that says the line parallel in one side of the triangle. That is one way in which you can put that thing. But there is another way that you can also use. So you can also say theorem, or if you want to use full word, you can say proportionality theorem since DE is parallel to BC. So if you use proportional theorem, then you must say that since DE is parallel to BC. But if you used this one, then you can just say line parallel to one side of a triangle. Then you can just continue with it. So that is how you show that I have used this theorem. So if you have used something like this, then you must have something like this or something like this accompanying it as something that validates your reasoning, to say that this is the reasoning that I used and that is why I'm using this result of this theorem. It's coming from this theorem, which is proportionality theorem. All right. Now, ladies and gentlemen, let us now try and find an example so that we can be able to express how this theorem is used. All right. Now, let's say we've got a problem like this. And then what do we say? Let me just put this thing here. Okay. So they just say find x. Find x, and then they give you a triangle. Now you must look at what you are given. So here is x. They are giving you a triangle. All right. And then now they are giving you this, and then they are giving you this, and then they are giving you this, and then they are not giving you this. They are saying you must look for this one. All right. Now, what are you going to do? All right. Now, you must notice something. Now, they are saying that DE is parallel to BC. So once they say DE is parallel to BC, then in your mind, you know that if I've got a triangle and then I've got this side that is parallel to another side, there is a theorem that I use in those kind of situations. And what is that theorem? It's a proportionality theorem. and then you know what it says, and then you know how you use it. All right. So now, if we did not know proportionality theorem, therefore there wouldn't be anything that relates this kind of a situation where you've got a triangle and then there is just a line that is parallel to the other side of the other side of the triangle. You wouldn't know what it does to the other two sides if you did not have proportionality theorem. So proportionality theorem is a glue that is able to pull all of these things together and helps us to find this. So when we are giving a solution here, so when we are giving a solution, so it's a solution. So what are we going to say? The first thing that we're going to say AD over DE is equal to what? Is equal to AE over what? Over EC. Now, why are we saying this? Because of we can say proportionality theorem, as we said earlier, or I'm going to use this other one, line parallel to one. You must choose what you're going to use. You can use any of the two. Line parallel to one side of the triangle. All right. Now, you have stated the result of proportionality theorem, and then you have said the reason. That's okay. I'm saying this because of proportionality theorem. And then now, what you need to do is then note that you are looking for EC. So your EC must be the subject of the formula. So what do you do here? You need to just cross multiply. When you cross multiply here, you're gonna say get this times this, which is what? Which is AD times, this dot is for times EC. And then you put an equal sign. And then if you multiply this and this, you're going to get DE multiplied by what? Multiplied by AE. Remember, you are looking for EC to be the subject of the formula so that you can be able to find what you are looking for. So what are you going to do? You're going to divide by AD here and then divide by AD here as well. Then this will cancel this, and then what are you going to remain with? You're going to remain with EC, right? EC, which is equal to what? Which is equal to DE multiplied by AE divided by AD. All right. Now you know EC is X, the one that you are looking for, equal to what is DE? Is it DE? Guys, we made a mistake, and then you know that in maths we do make a lot of mistakes sometimes. Okay, so let's sort it out. This is not supposed to be DE. We say AD over DB, so this is supposed to be B here. All right. So, and then if this is DB, or let's see if this one we made it fine. It's gonna be AE. Yes, it's AE, and then EC. Yes, this one is fine. It's this one that was a problem. Okay, and then let's sort it out at DB as well. All right, and then okay, we've got DB as well. Guys, it's normal in mathematics. We all make mistakes. Even myself, I am teaching maths, but I can make a mistake sometimes. Just as I've made it. Just now, let's just clarify. Let's just go back to all of these things so that we can make sure that we are in track. So we're saying AD over DB is equal to AE over EC. Okay, and then we cross multiply this, and then we cross multiply this, and then we get this and this, and then you saw what we did, and then we end up with this. And then EC is X, as you saw. And then what about DB? What about DB? dB is 4. dB is 4. And then what about AE? AE is 15. And then divided by, what about AD? What is AD? AD is 10. So this is 4 times 15, that is 60. And then divided by 10. And then that is going to be equal to what? It's going to give us 6. X is equal to 6. Okay? So guys, X is going to be 6 what? 6 units. In some cases, you will have centimeters. In some cases, you will have millimeters. And then if you don't have any of these things, you must just say 6 units. So ladies and gentlemen, here is our answer. Our answer is 6 units. Right? And we used proportionality theorem. All right? Now, did we understand what we're doing here? All right. Do we remember we're supposed to answer 5 questions? Now, if we want to check if we understand, what we were doing here, we should go back with what we intended to understand in the first place. We're looking at the proportionality theorem, and then wanted to know what it says, and now we know that it says that a line drawn parallel to one side of the triangle divides the other two sides proportionally or in the same proportion. And then what does it mean? We were able to explain that to say that it means that if I have a triangle and I just draw one line that is parallel to one side of the triangle, then I will know that that line divides the other two sides in a proportional manner. And then we say, when do we use proportionality theorem? We say number 1, we use it when we have number 1, a triangle, and then number 2, in that triangle we must have what? We must have one side that is parallel to the other side. So if we've got that situation, and then we are given some of the sides, and then there is a side that we are looking for, then we know that that is where we can use what? We can use proportionality theorem. And then another question is, how do you show that? Okay, number 1, how do we use it? That is the number 4. The fourth question was, how do we use it? And then guys, we just shown here, you can see here how you get to use it. You state it, and then when you state it, then you put the reasoning here. And this is a mark, ladies and gentlemen, and this is also a mark. And then after that, then you cross multiply, making what you are looking for to be the substitutive formula. In this case, it was EC. And then obviously put the appropriate value in terms of what you are given, and then calculate and solve. And don't forget that at the end, whatever you get, if it is in centimeter, then it's centimeter. If it was in millimeter, then it's millimeter here. But if there was nothing, then you must just say unit to show that this is something calculated in a certain unit. And then the last question is, how do we show that we have used it? We did say that in order to show that we have used it, we can either say, we can say 2 things. We can either say line parallel to one side of a triangle, or we can say proportionality theorem, and then semicolon, which means since in mathematics. So proportionality theorem since DE, which is this one, parallel to BC, which is this one. Ladies and gentlemen, personalities, thank you very much for your time. And guys, if you have any questions regarding this work that you have just done, or there is a proportionality theorem question that you struggled with, you can make a comment with it there. You can send us email. We can discuss it. You can discuss it on the comment. And if there's something that you did not agree with in what I was saying, you can also share it where in the comment section below, and then we discuss, and then we go further. And ladies and gentlemen, thank you very much for your time, and enjoy proportionality theorem in paper 2 of mathematics. Enjoy, ladies and gentlemen. My name is Mqondisi Macaba, and I love you all. Thank you.